Welcome to the Chief's Garage. In this video, we're going to test fit our crankshaft for the 331 stroker to see if we actually have to clearance the block. Now, there's a lot of folks that are saying yes, some are saying no. We have to check these things. So we're going to put the crank in, we're going to attach a rod, and we're going to rotate it and take a look and see what we need for clearance. One of the other things that we're going to do is I'm going to show you this tool that I showed you before. This is something that I adapted from something I saw on John Cossey Racing. And basically it is going to mimic the piston for our clearance and allow us to look down through the bore and from the bottom, and it centers the connecting rod in the bore. So what else are we going to do today? That's probably going to be about it. Once we test fit everything in, we're going to get the block clearanced if necessary, and then we'll go from there. Guys, if you're enjoying this, hit me up, give me a comment, let me know what you think. Let's get into it. So this is my process. What you're going to need to begin your crankshaft clearance checks is you're going to need, of course, the main caps. I'm only going to use 3. We're going to use number 1, number 3, because it's the thrust, and you need to be able to have your thrust bearing, and that's going to, locate your crankshaft correctly. And I'm going to use number 5. One of the other things that I use is to clean the crankshaft. I'm going to use some all-purpose wipes. These are lint-free. They're going to prevent you from having any dust or dirt anywhere. I always clean the crankshaft for this with some denatured alcohol. That's basically what you need. You can use any kind of cleaner, but I usually use alcohol. Some of the other things you're going to need is you're going to need upper and lower bearings for your mains. You're going to need at least one of your connecting rods. In most cases, if you have 2 connecting rods on the same pin, you would use 2, but I'll show you why I'm doing it this way when we get into it. Of course, your bearing for number 3, your thrust, is a little different. You're going to need that. In a previous video, we talked about this tool. This tool is going to allow us to not have to use one of our actual pistons, and I'll show you how that works. I've got a couple of go, no-go gauges that I've created. This is just a piece of electrical wire. It's 14 gauge, and if you measure this out, it comes out to be about 60 thousandths. This is our minimum for rotating clearance. And this is a piece of coat hanger. I've put it through a sanding process and got it down to 80 thousandths, which is ideal. And of course, you're going to need some way to be able to mark any of the areas where it's tight when you install your crankshaft. And I'm going to use a white marker for that. And we're going to cross our fingers that we don't actually have to do any grinding. Of course, this is a 331. There is a real possibility that when we put our connecting rod in, that because of how this design is, that we may not have to clearance anything. So cross your fingers, guys. Let's get after it. So I have the block all prepped. There's nothing going on here right now. It's just upside down. All the caps have been removed. You can see over here, I've got the crankshaft. It's all clean. It's all ready to go in there. And our next step is to put in the bearings and drop in the crank. And it's going to be like magic. So, and just like that, the crankshaft's in. And as you can see, it rotates just fine. And while I was off camera, I did a couple of other things, and that was to assemble the number 1 connecting rod along with the tool that, if you go back to my shorts, in my shorts, you will see that we made this tool based on something I saw on John Cossey Racing website. And so let me see if I can zoom this in for you guys so you guys can get a better look at what this is. And basically that piece of Delrin that I had been talking about, all I did was make that to the diameter of the piston, and you can see that it is now making itself, the piston is centered in the bore. It allows me to look down into the bore. I can see the top of the rod. I can see where it clearances from the bottom, which I think is a great idea. And as it swings around on this side of your lifter bore where your cam goes through, down here, you could possibly get into some interference. So what are we going to do now? I'm going to see if I can get the camera back set up here for you guys a little bit closer. We're going to rotate the engine around. And after I rotate the engine around to upside down, we will take a look at our clearances between our connecting rod and the structures in the block. All right, which should be somewhere around there. And give me a second here. See if I can get the camera set up a little closer to where you guys can actually see what's going on in here. So bear with me for a moment. Like I said, I'm a one-man band here. And want to lower that a little bit, see if I can zoom it in for you guys so you can actually see. Yeah, I'm making a bunch of noise here, but that's all right. As long as I get you to where I want you to see what I'm doing here. Because I need two hands, and I don't have a camera person. All right, and that looks pretty good right there. And I'm going to tighten that, and I can move the block a little bit if I have to. All right, so got the connecting rod in. The chamfered side of the rod is forward because the number one cylinder on a 302 passenger side forward, and this is passenger side. So chamfer is there against the crankshaft's chamfer. And you can see as I rotate this around, the Delrin device that we have in the cylinder is keeping the connecting rod perfectly straight as the piston would without having to drag my pistons up and through this when the block has not been final cleaned yet. And we're going to rotate this around. We're looking for wherever we have a clearance that's less than 60 thousandths. Now, I showed you guys my tools that I use for this. 14 gauge wire, which is 60, and this is a piece of coat hanger that I chucked up and spun around until I got it 80, and it's a measured 80 thousandths, and this is a measured 60 thousandths. And as I rotate the block around, my closest point of contact is the rod bolt right here. And you can see I put a white mark there, and I put that there as a reference so you guys can see. What we want is, we want at a minimum to have 60 thousandths here. Now, depending on what you look at, and the manufacturer of your rotating assembly may give you something different. Ideally, we would have 80 thousandths. So when I put that at its closest area of intersection to the bottom of the bore there, see, 80 thousandths will not fit there. When I get it right there in that spot, just the edge of the bolt itself will not allow 80 thousandths to pass through. And I'm keeping the piston all the way to the farther side of the chamfer, and I'm doing that for a reason, because if I move it this way, it opens up. See, it fits through there with no problem. But if I put this as close as I can, and which could possibly happen, I can't fit in 80 thousandths in there. Now, that's my no-go. It's green for a reason. This has to fit through there. If it doesn't fit, then we need to clearance the corner of the block right there. And so this is 60 thousandths. And that is my minimum for what I would put through there. So it fits there, and as I keep moving this, I can feel it get tight right there. Loose again. Tight. It fits through there. But there's a tight spot there. So what are we going to do? I'm going to go in with my die grinder, and I'm going to remove about 20 thousandths in this spot. We don't have any issue where our connecting rod throws get too close in here for our oil pump. We don't have any issues where we have that problem with this rod here, which would be our next tightest spot. And you can see there's no issue there. We don't have to take anything off there. And rotates around completely fine. No issues. So rather than put you guys through all of these, I'm going to magically go in, move this rod to the other side. I'm going to do that to each and every one of the crank throws from number 1 all the way through number 8. In any area where I cannot get 60 thousandths through, we're going to mark and we're going to clearance. Be back in a moment. And through the magic of cinema, you can see that I've already got the crankshaft back out and I've finished mocking up all the cylinders. And I'll see if we can get you in there close to see. Not every cylinder needed to be clearanced, but because I'm already here and the very little amount that I need to remove from each cylinder, I'm going to do them all. And so the tightest was probably here. On that number 5 cylinder. No issues in here with the oil pump. The SCAD 9000 series crank fits in this thing like a glove. I mean, it spun really good, even though it only had like 3 bearings in it and they're not torqued. I'm satisfied that when we looked at the bore alignment that it was good. Over here on this side, which is actually the passenger side of the engine, there is probably, I wouldn't have to really, clearance any of these, but as you can see, I've marked each of these and I'm going to go in and take out that little white mark right there on each and every cylinder. And that is going to allow us to have some insurance, and insurance is one of those things that when you need it, it's good to have it, but if that's just the way it is. So what I'm going to do next is I'm going to get this all covered in, and I'm not going to drag you guys through doing this. I'm debating on whether I want to use a double cut burr with an air tool, or something simple like a stone that I have for my Dremel, which is something that probably everyone could come up with pretty easily to do this. And that's what this is all about. Can you do this in your little 2-car garage? And the answer is yes. We've already mocked it up. We know where we need to remove. We kind of know how much we need to remove, because 60 thousandths just barely, is tight, just barely. So we're right on the edge of needing what we have already. All we're going to do is go in and clean that up. Then I'm going to deburr it, and we'll be back. Okay, so we got the patient ready for surgery. Of course, eye protection, and I'm going to do this with a Dremel. At least I'm going to try this first one with a Dremel, and because I think that's a tool that probably everyone has. And we'll see how this first one goes, and we'll go from there. Remember that we're just trying to remove this white area that's right here. So we're going to take our time, just take out this little area that's right here, take it down maybe about 20 thousandths, and that should be good enough. I'm going to put this on. Sorry about that, guys. That's loud. I'm going to put my Dremel on low speed. Of course, I don't usually wear gloves when I'm using my Dremel. That's one of those Navy things. It says when you're rotating equipment in your hand, you don't usually wear gloves. But I am wearing safety glasses, so let's go. And that, guys, is all that it takes. That is more than enough clearance that we need. I'm going to use a small jeweler's file here, and sorry, it's hot where we are and the air conditioner's on and you probably can hear that, but I'm going to use a little jeweler's file. Clean up the burr here on the edge. Come back and sand that later. And of course, we're going to go back and put the crankshaft back in this, and we are going to test this to make sure that we have the clearance we need. But that's all we need. That's enough to get our crankshaft to flow through that without causing any issues. And we're going to call that is good enough. I'll use a little tiny piece of sandpaper here. I'm going to roll it up and get rid of that burr. And that, guys, is all we need. Now, we're just going to wash and repeat 7 more times. All right. And so there you have it, guys. We've gotten through the entire block, got everything all clearanced on each of our cylinders. I've taken it down about the depth of my checker tool here, which is 60 thousandths, and I've done that to each of the cylinders, and as you can see, they're all dimpled now. And this side of the block over here, we didn't have a lot of issues with clearance. Some of these didn't actually need to be clearanced, but because we're there, we clearanced them anyway, so we'll have no issues in the future. So what's next? We need to get this outside and really get it power washed. There's a lot of debris, even though we, set this up as if we were doing surgery. There's a lot of debris in here that we need to get out. We still have not yet clearanced the block for bearings. We still need to put all the cam bearings in, and we need to get this thing painted. So first things first, we're gonna get it outside and get it all cleaned up. But as you can see, this isn't an overly difficult task, guys. Anyone with a Dremel and a little patience can do this. If you're not feeling confident about clearancing your own block for a stroker, just talk to your machine shop. The guys there would be more than happy to do that for you. And of course, there's a fee, but you could do this yourself. Just take your time. If this video has been helpful, like and subscribe. Tell someone about it. Share it with some other folks who may need or are working on something similar, and then get out there and build something.